So today's topic is about scatterplots and lines of best fit. So for example, you just make sure you need to define what a scatterplot is. So as I have here, a scatterplot is just a graph that shows a relationship between two data sets. Now the two data sets that we tend to plot together usually belong together. So sometimes we call them paired data. So like a quick example, there's like three different examples here. Like height and weight are two different data sets that normally pair well together. So I could pair them together and give you an ordered pair like this example here. So somebody who's 72 inches tall would weigh 175 pounds. Another thing that we might want to associate together because they relate to each other is your age and your height. So for example, age and height could be written as an ordered pair. So somebody who's 29 could be 175 pounds. Just another random example, how long you've been working somewhere and the amount of money you make. That obviously goes together, so it would make sense to pair the data set together. So a scatterplot is when we have a bunch of data from two different data sets, we write them together as ordered pairs, and we plot all those ordered pairs. Like here's a quick picture of one. So like this would be a scatterplot because I have a bunch of data points graphed on a coordinate plane. So when we make a scatterplot, the reason we're talking about scatterplots today is because when we make them, we can make trends way easier to see in the data. And if we can see the trend in the data, then we can use that trend to help model the data. In other words, like write an equation. That's kind of like what we mean by model. So we could look at what that looks like and then try to write an equation to model that data. Once we have a model, then we can use the equation to make predictions. So there's a lot of different models that we can use. So the trends that we're going to look at just as an introduction today, each trend will be a different type of function. So we've already seen some functions already this year. So some of those functions have been like the absolute value function we've seen lines, horizontal lines, vertical lines. So here's our like our first example is what you have in front of you. So the idea is what we can see here on this graph is we have the number of hours that have passed versus the amount of bacteria in a colony. So what they're asking us to do is what does the general trend look like? So first of all, what I can see is that I can see that this overall graph, if I try to connect the dots, kind of just looks like that, right? It doesn't look like it'd be a line. It doesn't follow that pattern of a line. It doesn't follow a pattern like this. I can see that if I just started connecting those dots one after another, it would look like that. And again, what I can do, if I can see that trend, then we could use it, we could write an equation to model that trend. Now, we haven't studied this exponential relationship yet. How would you describe that? So I do want you to write down exponential. We haven't studied it yet, but that's one way that we could see that pattern. So if I can describe the pattern, then once we have enough skills, then I should be able to like write an equation. So here I'm just using the computer to help me write an equation, but if I know that it's exponential, I can kind of play around with an equation and get it to look pretty good. So something like this, it doesn't go through every single data point, but it overall matches most of the data. So if I have that trend, then I can say that, oh, this is what most of the data looks like. So another example, here we can see this is the height of a ball after I have kicked it. So let me pull up that here. So here I can see that when I'm kicking a ball, obviously it starts low on the ground, it goes up in the air, and then as it reaches its maximum height, the ball should start coming back down to the ground. So like our first question here, they're just asking like, what is the general trend in the data? So if you had to connect the dots, what shape would it make? So I think that general shape, it would go up and then it would start to come back down. So the model that we describe here, again, we haven't really studied it yet, but this would be something called a quadratic model. So once I have that general shape, I'm going to go to my equation here. So my computer will do it for us. So like here, once we have the general shape and we know what it looks like, we can have the computer generate, or we can generate an equation. So this is the general quadratic shape. It's a U-shaped graph. So I can just like play around with some of these sliders and I'll post these links so you can do the same. But what I can do is I can generally match most of the data points. So maybe like I want it somewhere like negative, I don't know, I'm just playing around here, like negative 0.15, maybe just negative 0.1. Now that doesn't work exactly, but it fits most of the data points. So this is like the general trend of the ball, right? It goes in the air, then it starts to come back down. So once I have that general trend, I can use that model to predict when it would hit the ground, for instance. So like I drew in that path here. So you can see the path I modeled in red. I think it's going to hit the ground, I don't know, maybe about 15 seconds. And that's what we would see here on the one that we drew. If we continue to draw it, I think it would probably hit the ground just about 15 seconds. So we saw a trend. we drew the trend, and we used the trend to answer a question. Here's another relationship. So the graph to the left shows your distance from school after a certain amount of time has passed. So we start away from school, we walk to school, we get there, and then later eventually we leave school or something like that. So I have it on my computer just to make it a little more accurate. So if I were to ask you, how would you connect those dots? What's the general trend or pattern there? I think we would all see that it kind of fits that V-shaped pattern, right? I'm getting closer to school, and I'm probably going to keep going, and eventually I'm going to turn around and go home. So we just kind of drew and connected that dots there, and we should recognize this as an absolute value. So we can see the trend is like an absolute value trend. So if I was able to draw a model, just like I did there, we should be able to use that general model to predict when I would reach school. So if we're measuring the distance from school, when I reach school, that distance would be nothing. So it looks what, like 6, 6, whatever the unit is on time there. So 6 units. But again, we're able to see the overall pattern in the dots, connect them with a special shape, and then use that shape to make a prediction. What we want to focus on is this one, and this will take us to a little bit more of our work for today. So here what we have is a graph that is showing us the number of years of experience that somebody has at work, and the amount of money they make above the average employee. So here the general idea is if I had to say what is the overall trend in the data, I would just kind of say, well, it's increasing. It kind of just looks like a line like that. So this type of model we would call a linear model because it makes a line. So I'm going to go back to my computers to kind of model that for a second here. So I can adjust this line to kind of fit that data. So what's the y-intercept? What's the slope? So maybe like the y-intercept, I want it to start at that 2 value there. And then maybe the slope needs to be a little less steep. So maybe like 0.75 or something. And again, I'm just using my computer to generate that, but this essentially fits the data. It's not perfect. Some are above, some are below, but this is the overall trend in the data. So once I have that trend, I could answer a question. So for instance, it says, how much money above median do you think someone with 15 years of experience would make? Well, without the trend, we don't have that data, so I wouldn't be able to answer the question, but I can go ahead and just predict with that trend line. So like 15 would be like maybe like right here. So on my line, it looks to be about, if X was 15, maybe about 13,000 above the median. So I can use that line to predict 13,000 above. So those are just a bunch of different types of models we can make. So we're given a bunch of data points and we just connect them with a shape that seems to represent how they relate to each other. What we specifically want to focus on today we'll be writing trends for just lines, so just linear relationships, so just like the last one that we did. We'll eventually move forward in the year and use other models, but we're going to start with lines. So we're going to be given data, and we're going to try to model that data just with a line, and we're going to call that the line of best fit. So the line of best fit, if you kind of want to write that down, is just a line that models data. So that's just the line of best fit. So when we do this, there'll be an overall trend. The first thing we need to do is obviously get our data. So we need to either collect it or be given that data. Once we have the data, we're going to plot it on a graph. Once we plot it, just like we were before, we could just draw the line that tends to fit the data or represent the data's pattern. Once we have that line, we actually are going to write an equation of it. So we know when we were drawing that line, let's look at it this way. When we were drawing that line, here's some guidelines for us. Your line should obviously follow the general trend of the data. It doesn't need to go through every single point as long as it matches the overall pattern. It should go through some points if possible though, but again, it doesn't have to go through every single one. And if it's not going to go through every single point, we hope that the number of points that are above it and below it is about the same. So once we were to draw on that line, we now then have the ability to write the equation. So once we have a line, we can choose 2 points, get the slope, and put it into the best form. So just as a quick example, obviously you should write these down in your notes. This is like the general step of how we create a line of best fit. So here's like an example. So we're given a bunch of data, and in this data we have the temperature outside in degrees Celsius, and then we also have how much money in ice cream we have sold on that day. So it kind of makes sense to relate that data. How hot it is outside would relate to how much ice cream you sell. So if we're going to go ahead and just do this as an example, we're going to follow this list of steps. So we've already collected our data, and we're going to plot it on a graph. I already have this prepared on a graph, so I am going to go ahead and make that a little bit easier for myself. But again, I have all the data over here, so I'm going to go ahead and plot that. If you don't have that on a computer, maybe just take a moment to plot the data. So pause the video and plot the data as best as you can. Now, obviously, you're going to have to make some approximations when it comes to the scale that I've given you, but that is fine. So we're going to plot the data. All right, so I'm just going to start a new point here. So we've plotted the data. Now step number 2, after we've plotted the data, is to draw a line that best fits that data. So again, I have the ability to use a straight edge. So I'm going to try to draw a line that goes through as many points as possible. I know I can't go through everything, so I want to make sure that it has about the same number of lines above and below. So something like this is terrible. This does not follow the trend of the data. There's way too many points below it. Something like this is also terrible. All the points are above it. That's not good. So what I can do is I can start to connect some of these dots here maybe. So something like that, what I'm starting to realize, there's 1, 2, 3 points above it, 1, 2, 3, 4 points below it, and there's 1, 2, 3, 4, 5 points on it. So I think this is a really good line that would approximate the data. So I can extend that line, obviously. I want to draw it as long as I can. So this is the trend line. I think that if I had more data, either before 15 or after 25, they would fall approximately on that line. So once we've sketched the line, we've made sure it has the best trend. It doesn't go through all the points, but there's about the same number of points above as below. What I need to do is write the equation of that line. So I'm going to choose 2 points that are on that line. So for me, the 2 points that I'm going to choose, I'm going to go ahead and choose this first one right here. So I'm going to choose that point, and I'm also just going to choose that point. There's 2 points on the line, so I can go ahead and use them. Now, if we look at the data, that's the first and the last data point. So just labeling those data points, that's 14.2 and then 215 for the sales. And then up here, this is the point 17.2 and then 408. So once I have 2 points on a line, I can go ahead and just find the slope of that line. So our slope, which I can do at a different call, will be 408 minus 215 all over 17.2 minus 14.2. And I'm obviously just going to use my calculator, and I'm going to approximate this as best I can to decimal places. So 408 minus 215. So I get 193 on top. And on the bottom, 17.2 minus 14.2 is 3. So 193 divided by 3 is about 64.3. So now I have a point and I have a slope. So one equation I could write would be something like y minus 215 is equal to 64.3 times x minus 14.2. Another one I could do using the other point, y minus 408 is equal to 64.3 times x minus 17.2. But the idea is I've now taken the data and I've plotted it and approximated the equation of that data. So the equation that we've just written here, so to summarize for today, this equation will model how much money in ice cream we will sell given the temperature outside. So it wouldn't really matter which one we use, but as an example, I could ask myself like, okay, I don't have any data for a day that's exactly 25 degrees Celsius, but maybe there's a heat wave coming, and how much would I sell if it were 25 degrees out? Well, I could simply just plug that into my equation. I didn't have that data to begin with, but once I plug it into the equation, although I don't have the data, I can make a really good guess. So if I kind of put this through my calculator, which I encourage you to do, and then I get y alone, it tells me I should make about 64.3 times 25 minus 17.2. And I have to add the 408. It tells me I should make about $900 in sales. So again, I don't have that data point, but I use my line of best fit to approximate what it should be without having to actually wait for a day that's 25 degrees. So that's just a general intro of line of best fit. Make sure you have all your notes. We'll come back together in class and continue this idea.